Hi guys, welcome back to my channel. If you are new to this channel, please do subscribe to my channel and hit the bell icon for all the notifications. So this is a topic on the subject embedded systems. So I have made two videos on embedded systems, the introduction, applications and the challenges of embedded systems. The link will be down on the description box. You can refer to it. So the topic which we are going to cover today is hardware software co-design and program modeling. So first let's know what is hardware software co-design. In the early stage, we partition software and hardware. The software group deals with the implementation and the architecture of the software, whereas the hardware group deals with the construction of the hardware. And both of the groups will have very much less interaction. And after the completion of hardware and software, they will be integrated. The software and the hardware will be integrated at last. I have said in my previous video that software is being embedded into hardware. That's an example of embedded systems. Embedded systems are those, means if one thing is attached to another, then it is called as embedded systems. So now let's see the fundamental issues in the hardware and software co-design. The fundamental issues are model selection, architecture selection, language selection, partitioning of system requirements in hardware and software. These are the fundamental issues. Now let's see what is model selection. Let me tell you that if we are going to construct a house, then constructing the house is a final product. What's the first step to make a house? We have to draw a plan of it, right? We have to make a plan. In the same way, for a product, the final step is the product. The final step is the product itself, but the first step is the making of a model of it. From the model we are going to get the last final product. Okay, so to make this model we will need some requirements. So there will be some requirements to make this model, and from this requirement we will make the model, and from the model we go to further proceedings, and at last we will make the product. This is the steps which we are gonna do in every product completion. So this model describes, see the first line, first sentence: model describes system characteristics. Model contains subjects, objects and composition rules. It is hard to decide which model should be followed in a particular system design. So there are many types of models. It will be discussed further. So since there are many models, it is hard for the designers to stick on to one model. So designers switch between a variety of models depending on the requirements. So depending on the system requirements, these designers switch between a variety of models. Now let's go to architecture selection. Architecture selection, I have said to you that in model selection, the model describes the system characteristics, but the model will not explain how the system is being manufactured. It just give the characteristics of the system. It does not explain us the manufactured information. So this architecture helps for that. Architecture gives us the information of how the system is being manufactured. So see the second point: architecture specifies how a system is going to be implemented in terms of components and interconnections. So in architecture there will be components and interconnections. This architecture helps us in knowing that. So RISC, CISC, MIMD, SIMD are the common architectures. Now let's move on to language selection. We all know many programming languages like C, C++, Python, Java, etc. So this programming language help in capturing computational models. Yeah. So a model can be captured using many programming languages, and C, C++, C hash, Java are good for software implementation. See the third point: C++ is a good candidate for capturing object-oriented model. I have said to you that many programming languages can capture many type of models. So C++ programming language can capture object-oriented model. The last sentence is: for selecting a language, the prerequisite is that it should capture a model easily. If a programming language capture a model easily, it's a main vital step. That is the main important factor of for selecting a programming language. Now The last issue is partitioning of system requirements into hardware and software. So as I said you before, there will be system requirements to make a product, so we have to partition this into hardware and software. See the first point, it may be possible to implement the system requirements in either hardware or software. So we can implement the requirements into hardware and software according to our need. Software is firmware, and performance, reusability, effort, etc. are used for making a decision on the hardware software partitioning. So in hardware software partitioning, performance, reusability, effort, etc. are the main factors. So these are the issues of hardware software co-design. As I said you before, there are many models. So let's see what are the models. Computational models in embedded design. Data flow graph model, conditional data flow graph model, state machine model, sequential program model, concurrent process model. These are the models. As I said before, that designers feel it very much difficult to stick on to one model. Yeah, because of this reason, there are so many type of models. Now let's see the model each by each. Data flow graph model. Data flow graph model. Here the program execution is determined by the data. The name itself says that the model is mainly depending on data. Yeah, here the program execution is determined by the data. Here, as I said before, that there will be requirement. From the requirement we are making out final product. So the requirement is translated into data flow graph. So there will be a graph. This is from the requirement. We will make a graph. Data flow graph is being made. So a data flow graph model is a visual model where operations on the data is represented using a data. So in the requirement, if it is a mathematical requirement, means if it is a plus b, then plus is an operation, right? So plus will be represented in a circle, and data flow is represented using arrows. Means in a plus b there will be plus as operation. This a and b have to be given to this plus, right? So this flowing of this a and b is what is meant by data flow. That is being represented using arrow. Inward arrow to circle means input data. If in the circle we are giving an inward arrow, that means it is input data. Outward arrow from the circle is output data. If an arrow is coming out of the circle, that means it's an output data. Let's see, this is the example. Here the requirement is x equal to a plus b and y is equal to x minus c. See, so in x equal to a plus b, plus is the operation. So plus is, can you see the diagram? Plus is being represented in the circle. So a and b, to this plus, a and b is being given. So a and b is given to this plus. That means a and b is given as data flow. So a and b given to plus means a plus b, and x is coming out of it. That means x equal to a plus b. And this x is given to minus, and c is also given to minus, and y is coming as output. So y is equal to x minus c. That means y is equal to x minus c. This is data flow graph model. Now let's see conditional data flow graph model. This is same as data flow graph model, but there is a difference that here there will be condition. All are same, but here will be some conditions. Here it contains both data operations and control operations. In earlier one, in data flow graph model, there were only data operations. Since this is conditional data flow graph model, here control operations are also there. Data flow graph is elements and conditional are decision makers. So data flow graph is elements and conditionals. I think you might know flowchart, right? In flowchart we can see diamond shape, right? It is condition, right? And it is decision making as well. Yeah. Then this model has both data nodes and decision nodes, whereas DFG only has data nodes. Conditional data flow graph model has nodes and decision nodes because it has condition, and data flow graph model only has data nodes. As I said before, operations are represented in circle, data flow represented in arrow, and control node represented in diamond. See, this is the example of that. If flag equal to 1, x equal to a plus b, else y is equal to a minus b. This is the requirement. We have to make this requirement into this into this conditional data flow graph. So can you see flag equal to 1, question mark? This is the condition, that is control node. If it is true, then it is going to plus operation. That means a plus b is being executed and it is going out. See, and if flag equal to 1, is false, that means it is going to minus. That means A minus B is equal to y is being executed. So if a flag equal to 1, x equal to a plus b will be executed. Otherwise, y is equal to a minus b will be executed. That is control data flow graph model. Now let's go to sequential program model. The name itself says that the program is being executed in a sequence. Sequence means order by order. So in sequence program model, first point says that the processing requirements are executed in sequence. Here, the program instructions are iterated and executed conditionally, and the data gets transformed through a series of operations. See, data will be transformed through a series of operations, and FSMs are good choice for sequence program model. FSM stands for finite state machine. It will be discussed further. And flowchart is another important tool for modeling sequential programs. FSM represents states, events, transitions, and actions, whereas flowchart models the execution flow. We all draw flowchart, so we know what is flowchart. How it models the execution flow. Example is automatic seatbelt warning system. So requirement. So let me explain you what is automatic seatbelt warning system. So when we start the vehicle, and if we haven't tightened our seatbelt within 10 seconds, then the system will make an alarm. It is to make us caution that we have to wear the seatbelt. That is the automatic seatbelt warning system. So the requirement is the system should generate an alarm for 5 seconds if the ignition is on. Ignition is on means vehicle is started, and if the seatbelt is not tightened within 10 seconds. So if the vehicle is on, and if we haven't tightened the if the vehicle is on, and if we haven't tightened the seatbelt within 10 seconds, then the system is going to alarm, and alarm is for 5 seconds. So alarm will be turned off if the alarm time expire. If 5 seconds will be finished, then alarm will be off. Otherwise, if we wore the seatbelt, then too alarm will be off. Otherwise, ignition off means if the vehicle is off, then alarm will be off. These are the three conditions for the alarm to get off. Now let's see the diagram. See, first step is ignition key on. First of all, car or vehicle have to be started. Then wait for 10 seconds. The vehicle wait for 10 seconds. Again they are checking whether the ignition on or not. It is a decision condition. If the ignition is on is no, then end means vehicle is not on. That means we do not have to check anything. And if the vehicle is on, yes, then fourth one, see, seat belt on or not. They will check whether we have worn seat belt or not. Then if that is yes, we have worn the seat belt, then end. That means we have worn the seat belt, then there is no need to produce any alarm. So it is end. And if see the fifth step, if the seat belt on is no, that means set timer for 5 seconds and start alarm. So alarm will be started for 5 seconds. And next one, if ignition on, again, if ignition on is no, means if the car is not, if the vehicle is not started, that means end. If yes, that means they will again check whether the seat belt is on or not, means we have wore the seat belt or not. And if it is yes, if we wore the seat belt, then again if the I said before, right, alarm is being started. So if the seat belt is on, if we wore the seat belt, then alarm will be off. So stop alarm and end. Then see the third last step, time expired. If the time is expired, if it is yes, then stop alarm. Means if the time alarm time expire, again the alarm will be off. If alarm time expires no, then again they will check whether the ignition is on or not, and for the again these steps will be iterated. So that is the diagram of that. Now next one is state machine model. Here requirements are translated into sequence driven program. FSM, finite state machine model. I have explained to you, FSM is finite state machine model. Here the what is that, in this model states are finite. And HCFSM, the FSM and HCFSM are the types of state machine model, and HCFSM stands for hierarchical or concurrent finite state machine model. Here also example is automatic seatbelt warning system. It is state diagram. See, there are three states: alarm off, waiting, alarm on. So from alarm off, if this transition is to waiting, that means if the ignition key is on, then alarm off transition will be going to waiting. And in waiting state, the waiting state is changed to alarm on, means if the transition is to alarm on, then time have to time expire, means again what is ignition have to be on, vehicle have to be start, then vehicle wait for 10 seconds, that is this waiting state. If the vehicle is waiting for 10 seconds, that is here second state, waiting state. And time expire, that means 10 seconds is over, that means alarm will be on, this system produce an alarm, that is a third state. Again, alarm on will be changed to alarm off if the alarm time expires. See, from the third state, again it will go to first state if alarm time expire. As I said, when the alarm is on, if the time expire, if the 5 seconds of alarm get expired, then alarm will be off, otherwise seat belt have to be on. See, we can see from alarm on to alarm off, there's an arrow, and we can see three conditions: alarm time expire, seat belt on, ignition key off. That means if alarm time have to be expired, otherwise seat belt have to be on, that means we have to wear the seat belt, otherwise ignition key off, that means vehicle have to be stop off, that means in these three conditions alarm will be off. Okay, so and from waiting to alarm off, you can see from waiting to alarm off there are two conditions, that means ignition key off or seat belt on. So from waiting to alarm off, that means if say we have worn the seat belt, or if the vehicle is off, then waiting will be changed to alarm off, the first state. Next one is concurrent process model. This is the model executing tasks concurrently. In this model, tasks will be executed concurrently. That means if there are many tasks, all of them will be done parallelly. That means time will be used effectively. Some processing requirements are easier to model in concurrent processing model rather than conventional sequential model. Yeah, you all know. If there are many people who do a work, means we if there is a work, and what to say, if their work is divided into many parts, and each part is given to many people, then the work will get over so fast. But if you think that if one work is being done by one person, then he will take more time, right? So that is what is told by here. So if a work is done parallelly, or that means it is really effective. So processing requirements are easier to model in concurrent processing model rather than conventional sequential model. Sequential execution leads to a single execution of tasks, which leads to poor processor utilization, whereas in this model CPU usage is done effectively. In this model, CPU usage is effectively, means a concurrently process means CPU will be effectively used, and in sequential it is really lagging. Then the processing requirements are split into multiple tasks. Okay, there are requirements, right? This will be split into multiple tasks, and these tasks will be performed concurrently. So that is concurrent process model. So this was the fundamental issues and programming models of embedded systems. So I think you might have understood. Thanks for watching. I will come up with next video. Until then, bye bye.